Good day viewers, you are welcome to another video. Today I'm going to be showing you how to solve this, should I call it radical equation or quadratic equations, any of the two, because at the left hand side here we have a radical equation and at the right hand side we have a quadratic equations, which means we need to be very careful of this root that we cannot get negative values because it's going to lead us to an error, that is the invalid. And for this one, it can take anything as far as the number is concerned. But what of this? So let's see how we can find the value of z that satisfy these equations. Here, the first step we are going to take is, given this kind of question, we are going to take the square of both sides. And by doing that, here remains 5 minus z equals 5 minus z square all raised to power of 2, because this square has already negated this square root. And here is what we have. And when we try to expand this, here at the left hand side we have 5 minus z equals, the expansion of this becomes a is 25 minus 10z square plus z raised to power of 4. Here is what we are going to have. So the next thing is we are going to collect the like terms, or let's say we take everything to one side, so just to have everything equals 0. And by doing that, we have z raised to power of 4 minus 10z square plus 25 minus 5, or let's say we have plus z minus 5 equals 0. Here is what we are going to have. And this one is just like a quadratic equation because we have z raised to power of 4. And to save our stress, to save ourselves from stress, we are going to apply this geometry, because what I'm going to do here is very simple. And in our quadratic equation, what we are going to always make as a variable is the letter, not number. But today I'm going to be showing you how we are going to use number as a variable as well. Here we have 25 here, which you can express it as in a perfect square, which is 5 to the power of 2. By writing it, we have 5 to the power of 2. Then here we have minus 10z square, and here is 5. We can combine this together because we need the variable as 5. And this is only what we can combine together to have that 5 and form a quadratic equation. So we have this as minus, when we factor out 5, in the parentheses we have 2z square plus 1, then 5 outside. So which means the only number left is z and z raised to power of 4, which comes with positive. We have z raised to power 4 plus z equals 0. Wow, this is amazing. So on getting this thing, we compare it with a quadratic equation, which is the general form as ax square plus bx plus c equals 0. As from here, the value of a is the coefficient of 5 raised to power of 2, which is a equals 1, and b is the coefficient of this 5, which is minus open bracket 2z square plus 1, and the last one, which is c, we consider it as z raised to power 4 minus plus 4. We have it as z raised to power 4 plus z. And here is what we have here. So we are going to apply this quadratic formula, which is, instead of having x, we are going to have it as 5. Here we have 5 equals, minus b comes with this negative and it negates this. Therefore, we have 2z square plus 1. So we have plus or minus square root of, so we have b square, and this negative here because of square is going to become positive, and in this we have 2z square plus 1 all raised to power of 2 minus, and here is 4, a is 1, so we don't need it, and we have this c, which is z raised to power 4 plus z. divided by 2a, and the value of a here is 1, which is still remain 2. Then we have 5 equals 2z raised to power 2 plus 1 plus or minus square root of, when we expand this, we have it as 4z raised to power 4 plus 4z square plus 1. And here is minus 4z raised to power 4 minus 4z divided by 2. Next, we have 5 equals 2z square plus 1 plus or minus square root of, so something has already cancelled here. This and this cancelled each other, and we have 4z square plus 1 minus 4z. Everything here becomes 2z minus 1, all raised to power of 2 divided by 2. I hope we understand what I did here. So here we have 5 equals 2z square plus 1 plus or minus. So when this cancel this, here becomes 2z minus 1 divided by 2. And how quadratic works is, for positive we consider it separate, and for negative we also consider it separate. Let me just try to put parentheses here so that we will not get confused of this negative sign. Then for the positive side, we have 5 equals 2z square plus 1. Then we have plus 2z minus 1. The operation still remain the same because of positive. It doesn't have any effect on the other negative like that. So if it is negative, we still have it as negative when we multiply it with positive. A divided by 2. So we are considering the positive side and we are coming back to the negative. Here is 5 equals minus plus 1 cancelled, and here is 2z square plus 2z, but 2 comma, it can negate this. So here we have z square plus z only, and here we have z square plus z minus 5 equals 0, which is a quadratic equation. And when we solve this quadratic equation, what we are going to have is two values, and those two values are, we have minus 1 plus or minus square root of 21, if I'm not mistaken, divided by 2. Here is what we are going to have. And for the other part, which is negative, we are going to have it as 5 equals, we have 5 equals 2z square plus 1 plus or minus, so we are dealing with negative now, bracket 2z minus 1 divided by 2. Then we have 5 equals 2z square plus 1 minus 2z plus 1 divided by 2. And with this one, we have 5 equals, so this and this cannot cancel now, but when we add this and this together, we get 2. And 2 is also common to everything, which the end result is z raised to power 2 plus 1 minus 2z. And when we transfer this one to other side, we have this as z raised to power 2 minus, so here is still z because we have factored out 2. We have minus z, and here is minus 4. Everything equals 0. And when we solve this one, what we are going to have is z equals 1 plus or minus square root of 17 divided by 2. But from these 4 values that we got, it is only 2 that satisfy. That is the case of the negative, which will lead to complex because of the rational